Hello everyone. In today's video, I'm going to share with you how to go about answering GCE O-level questions from past year papers involving prime factorization to find perfect square and perfect cube. Let's take a look at the first question. It's taken from GCE O-level 2016, paper 1, question 18. I give you a couple of seconds to take a look at the question. You may pause my video at any time, okay? All right, I'm going to move on to the next slide so that we can go about solving the question 18. All right, part A. We have to find 784. All right, express it as a product of its prime factors. So when we see such a question, immediately we know we have to use repeated division. So let's do repeated division method to find 784 in its prime factors. So since 784 is an even number, we can divide it by 2. That gives us 392. It's still an even number. Let's proceed again. Giving us 196. We shall proceed. 98. Let's proceed. That gives us a 49. And 49 is an odd number and it cannot be divided by prime number 2, 3, 5. So we have to move on to the next prime number, which is 7. And we can proceed until we arrive at 1. Remember, repeated division stops when we arrive at 1 in the final repeated division process. So over here, we have a list of prime factors. Let me write down in index notation. So 2 to the power of 4, because 2 appearing 4 times, right? And then 7 to the power of 2 or 7 squared, because 7 appeared twice. Okay, we have already completed, we have already answered part A. Now to do part B, we have to use the answer from part A. And we are supposed to explain, to prove that 784 is a is a perfect square. So to do so, right, I want to write the product of the prime factors belonging to 784 in an expansion form. Okay, so I'm going to expand it to this way. 2 times 2 times 2 times 2. That is the meaning of 2 to the power of 4. 7 times 7. That means 7 to the power of 2. Now, what is the meaning of perfect square? Perfect square means the number can be divided, or rather the number can be square root. Again, perfect square means the number can be square root. Okay, let's recall in my past videos. 4 is a perfect square because square root of 4 gives us a 2. 36 is a perfect square. So square root 36 gives us a 6. 81 is a perfect square because when you square root 81, we get a 9. Okay, so perfect square has 2 identical sets, 2 identical pairs. Okay, so let's do pairing. Okay, let's do it now. All right, number 2 appear 4 times. Okay, so I shall group it this way. 1 pair, the next pair. Let's take a look at 7. There are only 2 7s here. Okay, then the first 7 belongs to the blue group, the blue group, and then the green one will be here. Okay, so rewriting this, I have this answer. 2 times 2 times 7 belongs to the blue pair. And then the green one will be 2 times 2 times 7 still because it is identical. That is the meaning of perfect square. Okay, so 2 to the power of 4 times 7 to the power of 2 can be written as 2 times 2. Okay, wait, let me write down in index notation. 2 square times 7. The whole thing is square. So when we do a square root of this expression, okay, right? So when we square root 2 square times 7 square, it gives us 2 square times 7. So this proves that 784 is a perfect square. Okay? Alright, now I'm going to use the next slide to do question 18, part C. Now, we are told that m and n are both prime numbers. Okay? So we are supposed to find the value of m and n so that this expression here is a perfect cube. Now, a perfect cube, we extend from the perfect square idea. Perfect cube will have 3 identical groups. Perfect square has 2 identical groups. Perfect cubed will have 3 identical groups. Okay, now to do this, we need to use the index notation of 784. Now, 784 is written as this way: 2 to the power of 4 times 7 to the power of 2. And then we want to multiply it by m over n, m out of n. Okay, and it has to be a perfect cube. So what does it mean? Okay, now I'm going to rewrite this in a fraction involving one numerator and one denominator. So the numerator becomes this, and the denominator is just n. Okay, just re-expressing it. Now, what is the value of m and n so that there will be 3 identical groups? Now, 3 identical groups means it must be in, there must be 3 sets of identical number 2 and 3 sets of identical number 7. Okay, all right, I'm going to rewrite this by expanding it. So, what do I have? 2 appearing 4 times, 7 appear 2 times, and we have a letter m. Whole thing is divided by n. Okay, we need to have 3 identical groups, right? Okay, come, let's take a look. Now, 3 identical groups, we have only 4 2's. Now, 4 2's cannot be split into 3 groups. We can't. So, we need to have 6 2's in order to do so. Okay? Alright, so it's okay. So, let's see. We need to have, we need to have 6 2's. Okay, so what we need to do is we need to have, or we can have to remove one particular 2. Okay, so like that. So let's say we have 3 this way. Okay, all right. So it's a group of 3 or 3 identical groups. Okay, so we can actually treat perfect cube as 3 identical groups or a group of 3's of the same kind. Okay, all right. So like that, right? Then how about 7? Okay, then 7 we can't, so it's okay. Assuming m belongs to 7. Right? Assuming m belongs to 7. Okay? So we need to get rid of these 2. We all need to get rid of these 2. So to get rid of these 2, we need to do the reverse of 2. That means we have to divide the expression by 2. Then 2 will be cancelled out. Okay? 2 will be removed. Meaning n has to be a 2. So when n is 2, where the denominator is 2, then the numerator 2 that is cancelled out in green will be divided away, you get a 1. So we remove 2 that way. So we have turned 2 to the power of 4 to become 2 to the power of 3. 2 to the power of 3 can be cube root. Okay? Alright. So how about the 7th category? So we have 7 times 7 times m, right? So to be able to be cube root, then the m has to be a 7. When m is a 7, then we have 7 cube. And 7 cube is indeed a perfect cube. Okay? So we have already answered part C. So what is the values of m and n? So m and n is as follows. M is 7, n is 2. Question 18 is done. Now let's move on to GCE O level 2012, question 9 of paper 1. I'll give you a couple of seconds to read through the questions. Okay, I'm going to go on to the next slide. The next slide, I will proceed to do the question. Okay, all right, there goes. Question A. Written as a product of its prime factors, 1008 is 2 to the power of s times 3 to the power of t times 7. So s and t are unknown numbers. So to find this, to do this, we have to do repeated division. Okay, I'm going to do it on the right side here. Okay, so I'm going to do it here. So 1008, even number. So we do which will start with prime number 2. So when we do this repeated division, we have 504. Let's proceed. We have this. We can still proceed further. We have 126 and we can still go on to get 63. 63. Can't use 2 anymore. We have to move on to a 3. We get 21. Okay, 21 cannot be divided by 2, cannot be divided by 3. The next prime number is a 5, so 21 definitely cannot be divided by 5. So we have to move on to a 7. So 7 gives us a final 3. Oh, there's another 3 there. Okay, so it's okay. We can still divide by 3 and we end with a 1. So this list tells us the prime factors of 1008. Okay, let's take a look. Let's write down in green. Okay, so let me use green. So 1008, okay, is equal to 2 how many times? Appearing how many times? 1, 2, 3, 4. 4 times. 3 appear how many times? Twice. And 7 is only 1. Okay, very good. 7 matches. Okay, so now what is the value of S now? What is the value of S? It's very obvious. S is 4. And what is the value of T? Also very obvious. T is 2. So A is done. Okay, all right. Next slide, we will talk about part B. Written an expression of its prime factors, 1350 is 2 times 3 cubed times 5 squared. Okay, let me copy this down. 2 times 3 cubed times 5 squared. Now, we are supposed to find what is the smallest positive integer k such that 1350 divided by k becomes a square number. A square number is a number that can be square root. Okay, all right. Okay, so what we do is we want this expression to be divided by k, meaning we want this in the expansion form to be divided by k, so that we get a number that can be square root. Okay, so what we need to do is we need to do some grouping. Okay, right? Okay, let's take a look. We have one, two here. Okay, alone, very lonely, number two. We have two fives here. This is good. This is good. That means the 5 times 5 can be square root. 5 times 5 is already a square number. Okay, then how about the one that is a 3? Let me choose another color. Let's say I take this. Now, this one is no good. This one is good. 3 times 3 alone is good. So, but this 3 is no good. So we shall keep this 3 times 3. We shall remove, okay, we shall remove what? We shall remove this 2. We shall remove this 3. So when we remove the 2, the one in red, and we remove the 3, the one that is yellow, we only get 3 times 3, and we are left with 3 times 3 times 5 times 5. 3 times 3 is 9, so it is a square number. 5 times 5 is 25. It's already a square number. So we have to remove this and this. So how to remove? Simple. Let's do this way. I'm going to rewrite 3 times 3 is what we want. 5 times 5 is what we want. Okay? And this is what we don't want. We don't want this. And the whole thing must be divided by k. So k must be this. So that this and these two are cancelled out. Okay? Then our new expression is a square number. So k is 2 times 3, which is 6. So A is done. Not difficult, right? Okay, let's take a look at the next GCE O-level question. The last one for my video. Give you a couple of seconds to take a look. Okay, in my next slide, we will go about solving GCE O-level question from the year 2011, paper 1, question 17. Okay, let's do the first one. Now, when written as the product of their prime factors, we have three expressions here. P, Q, and R. They have their own respective product of prime numbers, and they are all written in index notation. So A is asking us to find the value of the cube root of P. Okay, let's do that. So P is equal to 2 to the power of 3 times 3 to the power of 6. I'm going to expand this so that it is easier to spot the cube root. I have to write 3 more. 1, 2, 3, 4, 5. Okay. Oh, ridiculous here. Let me rewrite this part. Okay, we need to have 6 trees, right? 1, 2, 3, 4, 5, and 6. Okay, so in order for it to be able to be cube root, we must have a set of 3. So we have a set of 3. Okay, we have a set of 3. Okay, I use another color. Okay, let's say this one. Okay, okay. Let me write down this nicer, which is same as the one that is in green. So we have, oh, that's bad. Okay, all right, there goes. Okay, so now we do partnering. These two form one set, these two another set, and these two another set. So we have three identical set or three identical groups. Okay, so to find the cube root of P, we have already gotten the answer from here. So I'm going to write down here in my little space here. So when we do a cube root of P, we have 2 times 3 times, oh, bad choice of colors. Okay, let me redo. Cube root, that means with the 3 here of P will be this. Okay, and we are supposed to give the answer 18. All right, okay, all right. Why is that so? Because 2 times 3 times 3 has appeared 3 times. That's the value of P. 2 times 3 times 3 has appeared 3 times. This 3 here means there are 3 identical groups. So when we do a cube root, we get this value. Okay, so 2 times 3 times 3 is 18, give us 18. Okay, so part A is done. Okay, let's move on to part B. And part B, we need to use the value of the answers, all the values from A. Part B is asking us to find the LCM of P, Q, R, and our answer must be written in the product of its prime factors. Okay, can. Okay, so I'm going to rewrite the three expressions, so it's easier for us to compare. Oh, not very nice handwriting. I'm going to expand this instead. Okay, so 2 appearing 3 times and 3 appearing 6 times. 1, 2, 3, 4, 5, and 6. Okay, now this is not the only way to do, of course. Some of you are good in visualizing, then you don't have to do expansion. Okay, I've written P already. I'm going to write Q done. I'm going to write R. I hope I have not have extra value or fewer value. Okay, so let me take a quick look, quick check. P is equal to 2 to the power of 3, yes I have, and 3 to the power of 6, yes I have. And Q is equal to 2 times 3 squared times 5, yes I have. And R is equal to 2 squared times 3 times 7. Okay, excellent. Okay, now to get its LCM, okay, we must compare all three. Okay, come. They have this one set. So let's write down 2. Okay. Oh no. Okay. This one is one set. I do here. Okay, so 3 is one set. Oh, that's about all. So the lowest common multiple of PQR, okay? No, my apology. Actually, this method is for part C, HCF. Okay. Haha. Okay, I realize. Okay, this is HCF. Okay, everybody, I'm doing part C first. Okay, I'm doing part C first. Okay. All right. So this technique, this concept strategy is for HCF. Okay. All right. My sincerest apology. So this is a HCF way of solving. Okay, strategy. So HCF means we must have the minimum common. Okay. All right. So the HCF of PQR. Okay. This question C is asking for HCF because HCF is a factor that can divide all three exactly without a remainder. And we want it to be the greatest of all. So greatest means highest. So highest common factor. Okay, so the highest common factor is 6. Okay, my sincerest apology. This is part C. Okay. Pardon me, I'm going to go back to part B in my next slide. Okay. So in exams in school, if you accidentally do C first, it's okay. As long as you label your answer clearly, then the marker should have no issue following you. All right, that's what I did. So my bad. Okay, I'm going to move on to rewriting this again. So 2 cubed and 3 to the power of 6. Okay. All right, then Q. Okay, I forgot what's my color combination, but it's okay. So Q is this. Okay, and then my R is this. Okay, now what is LCM? What is indeed LCM? Okay, so LCM is to take the maximum. That means the number is multiplied, it's getting bigger. Okay, so P has 3 2's. So that is the maximum. Q has only 1 2, R has 2 2's. So no choice, we have to follow P. So 3 2's. Okay, now let's take a look at the digit 3. Factor 3, let's take a quick look. This one has 6 of them. Okay, Q has 2. So no, P is already 3 to the power of 6. Okay, so we shall follow 3 to the power of 6. Okay, use black. All right, okay, so we have 2 settled, 3 settled. Now we have still another one. We still have this. So we have to include the 5, and only Q has the factor 5, and R has a factor 7. Okay, any more comment? No more. So the LCM of PQR is 2 cubed times 3 to the power of 6 times 5 times 7. And if you use the calculator, it should give us a super big number, 204,120. So this is the answer for part B, LCM. Okay? All right. Remember to play back my video. All right. I've completed going through, discussing with you 3 examples from the GCE past year's questions. All right. Involving the use of prime factorization to solve questions on perfect square and perfect cube. Okay, I hope my video is not confusing to you. Okay, remember to play back and have a better understanding. Subscribe to my channel and you will get notified on all my future videos being posted. And if you like my today's video, give it a thumbs up, a like. Yes, I need your comments. Okay, your feedback, your comments, your motivation, right? So that I can produce better videos for you to assist you in your studies and share my video with others. This is Joseph. Thank you for following my channel. Thank you for watching this video. All right. Till then, see you again. Goodbye. Take care.